Um, Picking up then where we kind of left off from, we're talking today about different stakeholders and how you communicate with them effectively. That's generally the idea in a nutshell. How do you engage them in a meaningful conversation? We're going to think about that a little bit, and then how do you use the right media? And what Ken was just talking about social media, we're going to look at that a little bit actually as well. So, I'd like to start off doing is thinking about different stakeholders and who they might be. There are lots of, Ken's just spent a bit of time talking about the different stakeholders that the Life Sciences Society are interested in. But there are lots of potential stakeholders that people who are involved in research or involved in science, whether it's in life sciences or in astronomy or physics or chemistry, any area of research, that they would like to reach. And some of this really runs along those similar lines to what Ken was talking about. It could be researchers in other fields, because quite often you want to reach researchers who work in a slightly different field to your own research. Because these days, scientists are encouraged to do transdisciplinary research. They're encouraged to work with people who aren't in their immediate discipline. It might be investors. It might be people who might invest money in your area of research. It might be policymakers. So people who work within government and who might be able to provide you with funding, or might kind of set the rules in which your research takes place and decide and sort of formulate policies that influence how your research is done in some way, what's allowed, what's not allowed, what areas are priorities for funding, and all those sorts of things. So policymakers are important to reach out to. It could be young people. So it might be young people in terms of inspiring them to get to be involved and interested in your area of research, because quite often many of us are kind of interested in our own research because we were inspired by teachers in the past. It could be university students and funders, obviously, people who might pay money, and practitioners. Some of your research might relate to people who are medical doctors or others like psychiatrists and so on, that your research might help them to do their jobs in the future and have a real impact in that way. As I mentioned at the start, one of the things that I was asked to talk about here, and I was really intrigued by it when I saw it on the brief, was this idea of having meaningful conversations with a stakeholder. So I spent a bit of time thinking, what would a meaningful conversation look like? What does that actually mean? If you have a meaningful conversation with someone, what does that actually entail? So firstly, I mean, some of these are fairly obvious. Like, first one is, it's a conversation in which both people understand one another. Because to have a good, meaningful conversation, you both need to understand what each other's saying. You also both need to be interested in it, because if someone's not interested, the conversation isn't going to lead anywhere. It's not going to lead to anything that would be of use. And finally, for the conversation to be meaningful, there needs to be some kind of outcome. It's not just a case of having a conversation. There needs to be something that comes of it at the end. And it could be a kind of a decision that's taken, or an agreement, or even just a decision to have another conversation about something else. So in thinking about communication and the way that science is communicated, sometimes you might want to communicate science with people that you want to have one of these meaningful conversations. So looking at this list, they need to understand you. They need to be interested in what you have to say. But also, you would hope that there would be some kind of outcome. So dependent on who the stakeholder is, you might want a different kind of outcome. So this is where I'd like you to do a bit of thinking about how this will apply to you. How would which kind of stakeholder, given your area of interest, your area of work, your area of research, which stakeholders would you be most interested in reaching, and why? So in thinking about this, there's a technique that is actually used quite often in software design. And it's an approach that encourages you to think about the other person and see something from their perspective. And it uses these three starts of sentences. And it's as a, I want to, so I can. So in terms of software development, it's applied to thinking about different people who might use a piece of software. So say, for instance, you work for a software company and you're developing a piece of software that might be used by students. You know, it might be used by students to help them write essays or something like that. So they would think about this from the perspective as a student. As a student, I want to write my essays really well so I can get a really good mark. That's what they're thinking about. So then they use that information to then help them develop their software. What is it they can do to develop their software that will help this person, this student, with what they want to do and ultimately develop a really useful piece of software? So I want to adapt that framework and that way of thinking to this context and communicating scientific research, and use it to think about the stakeholders who you might want to reach and talk about your research. So whether it's students at university or policymakers or funders or young people, whoever it is, you choose. I want you to think about these three questions. So as a whoever, I want to, what do they want? What would they want from some kind of communication with you so I can? And so what's the reason behind wanting to do that? So what I would like you to do is pick out two of the stakeholders who are here. So which two stakeholders would you like to reach? And I would like you to think about these three things for them. So as a policymaker, I want to, so I can, and so on. Okay? So Article 1, that was from The Scientist publication, which perhaps unsurprisingly is aimed at scientists. So yeah, professional magazine for scientists. It includes things like career news and job opportunities and things like that. But I think you were spot on in what you said, far more formal language. It assumes far more knowledge. There's a lot of technical terms in there that aren't explained to the reader. Whereas with the other article that was in a publication that's called IFL Science, so I love science. I won't say what the F stands for because we're in polite company, but that's aimed at young readers. It's aimed at readers who are aged 18 to 34 who've got an interest in science, but not necessarily a science background. So it's aimed at young people, so it's far more conversational, far lighter. And as you said, it kind of picked out some key takeaway information. And I think there was a kind of key difference that one of you mentioned, which is kind of the Article 2 was mainly written from the perspective of you as someone who might be having the vaccine, whereas obviously Article 1 was written very much in this kind of conveying information to other scientists. So we can see that the same piece of research has been communicated very differently for different audiences. And those differences involve many things. So it involves differences in the technical language, because we're assuming their knowledge about science is different. So readers of The Scientist will have far greater scientific knowledge than readers of IFL Science. But also, the tone is different. The way that you're addressing the reader is different. Much as you might do in a conversation naturally, they're doing that in this written form. And there's so in those two different examples, there's quite a lot to pick apart in terms of how they've tackled these two different articles for different readers. So this is the research study where that I just wanted to show you this very briefly. This is the research study that prompted both of those both articles. So yeah, looking at the sort of risks associated with blood clots associated with the vaccine or a vaccine. What I'd suggest is that because I've been talking for a little bit, we'll keep going for another quarter of an hour, and then let's have a break for 10 minutes. So that you can get a drink and kind of refresh, and then we'll carry on, because it's quite hard work staring at a screen for so long, isn't it? So let's have a break in 15 minutes. We'll have a break, but we'll keep going in the meantime. This I wanted to show you this just as a kind of a bit of a change of topic, but related to what we've been looking at. It's not got much to do with communicating. Well, I suppose it's got communicating with members of the public in mind. This is something to think about. So I don't know whether it's been a big story in Hong Kong, but the risk associated with the coronavirus vaccine, and the fact that there's a very, very, very small risk associated with them. But nevertheless, it's been in the news. Loads of people are having the vaccine and people are talking about this. What are the risks? And a few weeks ago, there was new research that came out that basically said the chance of the likelihood of getting a blood clot after a dose of the Oxford AstraZeneca COVID-19 vaccine is approximately 4 million. And what a lot of and they also said that because of the number of people who died from the blood clots, it meant that there was a 1 in a million chance, of dying from a blood clot after getting this particular vaccine. So what a lot of newspapers said, well, what does that mean? How can people understand 1 in a million chance? So then they started searching around for other things where there was a very low risk, other things that there was a very low risk of dying from. And they found a statistic that showed that essentially there's a 1 in a million chance of being killed by a cow. So they basically said, you've got as much risk of being killed by a cow as you have of dying from a blood clot after taking this particular vaccine. So the reason I want to mention this, there is a kind of a wider picture. Not only is it quite an interesting way to try and explain risk to members of the public, but also I wanted to mention an organisation called Full Fact, because probably a lot of you are sort of aware of the challenges on social media in relation to science and misinformation and the sort of information that people get wrong, that is, that people read that is incorrect about things like vaccines. But now it's led to a growth of organisations, a growth of often they're charities who are trying to combat misinformation. And one of the things that they did was to check the facts behind this claim that the risk of dying from blood clot after taking the vaccine is about the same as the risk of being killed by a cow. And they did the fact checking of that. And it turns out it's actually true. But I just wanted to use it as an opportunity to talk about a big phenomenon in science communication, and that is the misinformation online, but also the growth of organisations that are out there to kind of check facts, to check the facts of journalists. So moving back to communicating with different stakeholders. we looked in those two different articles at the way that they had been written, bearing in mind they're very different audiences. So one was a scientist, one was a member of the public. And there were several different factors that told us that. There were different levels of assumed knowledge. So how much knowledge did we think, the readers of the scientist have compared to IFL science? But there were also differences in tone between the two publications as well. So one was more conversational than the other. And the way that I like to think about how you communicate science effectively with different audiences or different stakeholders is to think of a series of spectrums of how you might communicate that topic with them. So you have one spectrum that we've seen already, which is about the tone of that communication. So on the one extreme, your tone could be very informal, very conversational, explaining something like you might explain it to your best friend in that kind of free, very informal way. Whereas on the other extreme is a very formal way of explaining something. Like in the scientist article, say if you're doing a very formal presentation, you're presenting your results of your PhD or whatever, very, very formal way of explaining something. There's also the language that's used, how many scientific terms you use. So either very sort of simple language with very few scientific terms, or complicated with many scientific terms. And the content itself, it's not just about the language, but also how much have you explained the science as well? So how much have you assumed your audience knows about different topics? So, on the one extreme, very little scientific knowledge assumed. On the other extreme, very high level. So we saw in the scientist article that quite technical terms were used without being explained at all. And there was not a lot of explanation about the science itself. Let me just have a quick flick back who mentioned about this. So it was Sapphire who mentioned the fact that Article 1 requires knowledge of mRNA versus vector-based vaccine. So, you can see here, and that was in the scientist article, whereas the one for IFL science didn't require that. So you can see that there are, they're on different places on this spectrum. And essentially, the sort of the key message is the art of good communication with different stakeholders and different audiences involves you actively thinking about these spectrums. Where would your readers, your listeners, your viewers, where would they sit on these different spectrums? So again, it's a simple idea, but one that's really quite effective in making sure that your readers are going to understand what it is that you want to explain to them. So as I said here, like the level of assumed knowledge helps you know how many things it is that you're going to need to explain. So within that last article, do you need to explain what mRNA is, and a vector-based vaccine? Or is that something that your readers already know? So it's quite important to know about how much kind of assumed knowledge they have.